Hello, math students. Welcome back to Module 3, Expressions and Equations. This is Lesson 5, and it is called Collecting Rational-like Terms. Collecting rational-like terms, okay? And our goal for today is, today we will write number expressions by collecting like terms and using the distributive property. Question that I want you to think about when you're working with this lesson is, what must you remember when combining like terms? All right, so some things to know. The rules for combining like terms. The rules for combining like terms are very simple. The thing you have to remember is that if something has something in common, then you can combine it. If it doesn't have anything in common, then you can't combine it. And if you can remember that, that's going to make everything in math that we're doing from here on out a lot easier. So you have to remember, if it has something in common, then you can put it together. If it doesn't have anything in common, you cannot, okay? And so let's look at this first expression that we see. And remember, we've been working with expressions, and expressions are number sentences that do not have an equal sign. So as you can see right here, there is no equal sign on this expression at all. The only thing that you see is you see adding, subtracting, adding, adding, subtracting, adding. Okay, so those are the operations that we have right there. And then the other thing that you need to remember and notice is that because it's an expression, you're only going to combine things based on what the operation that is sitting next to it says to do. And so I'm going to go ahead, and I don't know if you can see this, but I went ahead and I circled all of the operations that are present in that sentence with yellow so that we can see where we are at. So the first thing that I like to do when I am working with combining like terms is I like to look for the parts of the expression. So if you can go ahead and find all of the math operations that are in there, it allows your eyes and it allows your brain to separate everything into parts, okay? So I'm looking for parts of the expression. I see an I here. I see 6I right here. I see 3/7 I here. I see 1/3 H here. I see 1/2 I here. I see an H here. And then I see 1/4 H here. So I'm already starting to notice that when I am working on combining them, that I'm trying to find the parts. So the parts that I see within this problem is that some of them have I's and the others have H's. So there's only two types of terms that we see. And the types that you need to pay attention to is this one has an I, this one has an I, this one has an I, and this one has an I right here, okay? Versus the other ones, they all have H's. So if you look at it, this one has an H right here, this one has an H right here, and this one has an H right there. So you can see that there are only two types of terms that you're going to be combining. So the second thing is you make all the common parts a certain way. So here they are separated out. So we have I, and we have H, and H, okay? So we put all of the I's together, and so I'm going to go ahead and put boxes around all of the I's using this purple, okay? Because all of these have I's, and then all of these have H's, so I'm going to put blue circles around all of the H's. Now, some of you are going, why is she doing boxes? Why is she doing circles? Well, the reason why I like to do boxes and I like to do circles and I like to use different colors is because it naturally forces my brain to go, oh, you're a circle, you have to be in this group. Oh, you're a square or a rectangle, you have to be in this group. And so it helps my brain keep them separated so that I know that what I'm doing with them. Okay, so then it says, second, make all of the common parts a certain way. Well, the problem with this is I see this is a whole number, and for some of you it may be bugging you, so I can put the number 1 right there. And then I see this is a whole number, and I see this is a fraction, and I see this is a fraction. And if you've ever learned anything about working with numbers, when you have fractions and whole numbers together, you have to be able to combine them. And the only way that you can combine or separate fractional pieces is if they have a common denominator. And so what I say to do in this second step is make all the common parts a certain way. I've decided that I'm going to turn all of these into fractional pieces. So this 1I right here becomes the fraction 7/7 I. And the reason why is because if you take 7 divided by 7, you get a 1. So that covers that. Okay. Then 6i, making it have a fraction with a common denominator of 7, is I say, okay, this would really be 6 over 1. And then if I'm trying to have a common denominator of 7, then I would have to take, let me show you the work over here so that you don't get confused. So I had 6. I changed it to 6 over 1, right? And that's I, because that's what this guy is right here. Then I'm trying to turn it into a common denominator of 7. So how do I get from 1 to 7? I times by 7. What you do to one side, you have to do the other, times by 7. 1 times 7 is 7. 6 times 7 is 42. So now you see that 6i really becomes 42/7 I. And you watched the math over here to see how to do that. Then I already have this one as a fraction, so I can just leave it as is, and that becomes 3/7. And then this one's already a fraction also, so I left it as 1/2. Okay? Does everybody understand what I'm doing? Hopefully you do. This one is already a fraction, so I left it as 1/3. This one right here is really a 1h, and so I can turn 1h into 3/3 because 3 divided by 3 is actually 1. So that one would be 3/3, and this one already is a fraction of 1/4, so I left it as a fraction. So in the second step, it says make all common parts a certain way, so all of them are now fractions, okay? So then the third thing says, third, combine them to make the expression simplified. Well, I do have to combine, but the problem is with combining, if you remember, they have to have a common denominator. So now let's go back and look at these. This is 7ths, 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 halves. And I'm going to stop right there because these all have i's, the letter I attached to them. So because they all have the i's and they're all purple and they were all rectangles, I have to put all of these together in a simplified group. But the problem with that is I have 7ths, 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 and halves. And so you can't have 7ths, 7ths, 7ths combined and then combine it with a half because you've already learned this for fractions. You have to have a common denominator. So I decided the common denominator between 7 and 2 is 14. So if you look, 7/7 would become 14/14. 42/7 would become 84/14. 3/7 would become 6/14. And 1/2 would become 7/14. Now I have all common denominators, and now I can use those mathematical operations that we've been working with to figure them out. So this one says 14/14 I plus 84/14 I. So remember, when you're adding fractions, all you do is keep the denominator to the same. So this would remain as 14, right? But then you add the numerators. So 4 plus 4 is 8. 8 plus 1 is 9, and now those two combined make 98/14 I, okay? And now I would like to also look at this one right here, and we're going to go ahead and combine these two first. So we have these two, again, remembering that the common denominator stays the same, and we're adding the numerator, so 6 plus 7 is 13i, right? So we have that. And then the last step that it says to do right here is that you are going to subtract them, okay? So then on this side, the last thing that we're going to do is we are going to subtract these, remembering that the denominator stays the same. So I have 14ths right there, right? And then I'm going to take 98 minus 13. Well, 8 minus 3 is 5, and 9 minus 1 is 8. And so this answer for this term of I is 85/14 I. Okay? So that's smaller, isn't it? So what it says up here is third, combine them to make the expression simplified. So we simplified it down into this one term right here. So now we have to do the other side. Okay, so going back to what we talked about is you have to have a common denominator, and if you look at this, I have thirds, thirds, and fourths, and these all have h's right here. And so we have to combine them, but we know that they have to have a common denominator. So the common denominator between 3 and 4 on this one, I came up with 12. So 1/3 h becomes 4/12 h. 3/3 h becomes 12/12 h. And 1/4 H becomes 3/12 H. And now we're going to do what we did on the other side where we combine. So again, I'm going to start with these guys right here, like I did before. And so if we take a look at this, we have this right here, and we have 12/12 H plus 3/12 H, remembering that the denominator stays the same, and 12 plus 3 is 15, and this is H. And now we have to look at this operation right here, which was subtract, so we have to bring that down here, and this right here is already 12, so we have 4/12 H minus 15/12 H, and so we're knowing that we're combining these two, and so our denominator would be 12, and then we would say 4 minus 15. So if we're thinking about it, we have 4 positive chips and we have 15 negative chips. When you put the 4 positives with 4 of the negatives, those become 0 pairs, and you're left with negative 11/12 H. And so that right there, if you're looking at this operation that combines these two different groups, that says plus. So our answer, our final simplified expression for this combining like terms is 85/14 I plus negative 11/12 H. And that would be your finalized simplified expression. Okay? So that one was kind of scary. It was kind of huge. It was kind of big. But the most important thing that you have to remember in this lesson is it cannot be combined if it doesn't have it in common. So we separated everything that was uncommon and put it on the same side, separated everything that was in common, put it on the same side, and then we went through the steps to be able to combine them. And you're going to have to do that with problems that you see in your practice when we get into class. Okay? So going back to our goal for today, we will write number expressions by collecting like terms and using the distributive property. Remember what you must, or what must you remember when you're combining like terms? The most important thing to remember when you are combining like terms is that they have to have something in common in order to combine them. Okay, they have to have something in common in order to combine them. Really quickly, I would like to just cover that distributive property thing that it said in our goal, and remembering that the distributive property is something like this, where if you have 3 times the quantity x plus 2, right? And so what they were talking about with that distributive property, remember, this number right here tells you the number of tapes. So I need 1, 2, 3. And then what goes inside the tapes is I have x and I have a 2. I have x and I have a 2. I have x and I have a 2. And then you have to simplify what you have. So I see 1, 2, 3, 3 x's. And then I see 2, 4, 6 plus 6. And that's all you can do because this one has an x and this one does not. So again, combining like terms, today we will write number expressions by collecting like terms and using the distributive property, and then remembering that you can only put them together if they have something in common. This one does not have just 3, it has 3x. So it cannot be combined with the 6 because the 6 does not have any x's. Okay? All right, kiddos, that's all I have for you in this lesson. I'll talk to you soon. Bye!